Okay, and welcome folks to another lab demo. This time I plan to demonstrate mechanical governor adjustments. We're going to set the static and dynamic settings, but before we get into filling out the lab sheet, let's talk about our setup and tools that we'll need. So let me pull you from the mount here. You're going to need either the orange engine that you see here, or you're going to need this white one here, and you can see that they're bolted to a cart. And then you're going to want to have an exhaust set up also, which you can see here. I've got the exhaust stand, and that goes to one of the exhaust ports in the floor. Note, till I build a slightly taller stand, you might have to prop it up in a box in order to get the proper adjustment height. So we'll need access to one of these engines for this lab. Let me show you the tools next. So for tools and equipment here, we're going to start out with wanting a pair of earmuffs because you're going to be right next to an engine running at top no load speed, and it gets kind of loud. And depending on your engine, you may need only a couple or several of these tools. For our particular engine today, we're going to need a 1/4-inch nut driver and a flat blade screwdriver, either the carb adjustment style with the ring around it or just a regular flathead that fits well. Some engines may require a Torx driver or a Phillips or JIS screwdriver, cross point. We'll need a tachometer, and I'll show you how we use that. And I have some shop-made governor tools here for the style governors where you have to bend the spring anchor or tang. So this is just another one like this. You can buy tools like this, but we just made a few here at the shop. And then you're going to need a appropriate service manual for the particular engine you're going to be adjusting the governor on as well. So let's get back over to the engine. We'll get started on filling in the lab sheet, and we'll talk about static governor adjustments. Okay, so the first thing that we're going to want to do is record our engine numbers so that we can look up any pertinent information that we need to. And for our particular engine here, the engine numbers are stamped into the shroud right here. They're a little bit hard to read because they're rusty, so I'm going to go ahead and read it off for you and write it down here. So the engine manufacturer is a Tecumseh. Okay, that was actually Craftsman machine that it came from, and I'll show you why I know that in just a moment. The numbers that are actually stamped into the shroud are 143.694012 SER 92330. So whenever you see that 143 point number, that pretty much indicates that this is a Tecumseh engine that was sold to Craftsman, and it was a Craftsman machine. We know that this is a horizontal shaft engine, and if possible, we'll look up the recommended idle speed and the recommended maximum speed. But let's go take a look at the manual and take a look at the numbers. So this Tecumseh manual has a Sears Craftsman cross-reference chart in the back of it. And if you take a look, all of these numbers pretty much start with 143 dash something. And so I've gone ahead and pre-found the number for us. And if we take a look right down here, we've got 143.694012. And if we come over here and we look, we can see that our Tecumseh model number is an H35 with a spec number of 45528L. So that's how we figure that out. Then that would allow us to jump over to the governor section and look up whatever we need to for the governor. As you can see, there's a variety of style of governor gears. This is the generic setup here and what we're going to be working with. Our static adjustment is going to help us eliminate the slack from the throttle shaft through the linkage, through the arm, through the governor lever, all the way to the spool. And then our dynamic one we'll deal with our engine speed and RPM. Now for this particular lab and engine here, we're going to go ahead and use some numbers because this book doesn't actually have specific RPMs for us. So we're going to go ahead and set the idle speed to 2,000 RPM. That's a little bit fast, but it'll give us a nice stable idle RPM for this single cylinder engine. And then I'm going to go ahead and set the recommended maximum speed to 3,400 RPM for this particular demonstration. All right, back over to the engine. Okay, so let's talk about static governor adjustments. Let's take a look at our lab sheet here. If at all possible, we want to locate the specific setting instructions for your specific engine, which may or may not be the same as the one I'm using for example here, because they do vary from one engine to another. In the case that you cannot find specific information for it, I have a generic process laid out in the instructions, which seems to work in many circumstances, but not necessarily all. The very first thing we're going to do is go ahead and make sure all the linkages, springs, levers, and everything are hooked up and in good condition. Nothing's binding or excessively worn out, loose. There's no stretch springs, things like that. That all needs to get repaired or replaced before we begin any adjustments. With the engine off, we're going to go ahead and loosen the screw holding the governor clamp on the governor lever, and then we're going to rotate the clamp in the direction that would cause the throttle to open. And then we're going to push the governor lever into the same direction that would cause the throttle to go wide open. While holding everything together, we tighten down the screw. So let's see what that looks like with our engine here. Right here is the governor shaft that goes into the engine, and then this part right here that has the bolt in it is our governor clamp. This piece is our governor arm. This is our governor link that goes into the carburetor throttle shaft up here. And then you can see the governor spring behind the carburetor bowl right here. Over on this side is our speed selector lever. So when I do my static adjustments, I oftentimes want my speed selector lever, if equipped, in the idle position. So what we're going to do is we're going to loosen this bolt, and we're going to rotate this in the same direction that would cause the throttle to open, which, as you can see, would be the clockwise direction for this particular engine. Then while I'm rotating this, I need to make sure to push the lever over too. Before I go ahead and actually do anything, let me show you what a properly adjusted governor starts and runs at, and then I will purposely misadjust it, and I'll show you how it behaves differently, and then I will go back and I will show the process of resetting the static adjustment, and then we'll move on to the dynamic one, as well as I'll show you how to use the vibration tachometer. So I'm going to go ahead and start up the exhaust. Okay, so this is going to be normal operation with the properly set governor. Shouldn't need too much choke. I'm at idle. Maybe a little bit of prime. As you can see, it starts, it runs up to top no load speed, and it stays there at a steady, stable RPM. That's what we want in a properly adjusted governor. So I'm going to go ahead and misadjust the governor now, and we'll see what happens with it misadjusted. I just loosened it and randomly retightened it. So let's go ahead and restart it. You'll note that the engine starts and idles fine, but when we go to wide open throttle or top no load speed, you'll notice that when we go to bring it up to full speed, it goes well above what it should for a maximum engine speed. That's because the governor no longer has control over the engine. So let me turn off the exhaust and I'll explain how to set it right. Alright, so to actually set the governor properly, I'm going to take my nut driver and I'm going to re-loosen this governor clamp screw or bolt here. And I need to rotate my governor. On this particular engine, it's going to be clockwise because that will cause the throttle shaft up on the carburetor here to open. So I'm going to rotate the clamp clockwise. While holding that clockwise, I also want to push the governor arm and link and the carburetor throttle plate to the wide open throttle position. While holding it in this position, this takes all the slack out of the system so that the governor can actually push against the throttle to bring it to a close. So while holding it, I'm going to take my nut driver and I'm going to re-snug that screw. We don't need to crank down on the screw because the screw only goes into a couple of threads on the sheet metal clamp there. So just snug is all we need. But once I have that set, that should eliminate any slack in my governor system. And now when I restart the engine, we should see that the governor is able to control the maximum engine speed once again. So let me turn the exhaust back on and we'll start it up and see. So now with the exhaust on once again, we'll go ahead and start it. The idle's pretty stable, so we'll bring it up to So you can see, even with manipulating the throttle, once I let go of it, the governor is able to restore a stable top no load speed. So the governor once again has control over the engine. So let me turn the exhaust off and we'll talk about the dynamic setting for top no load speed now. Okay, so for this particular engine, the top no load speed or dynamic governor setting is accomplished with an adjustment screw right here. Right now these speed selector switches in the off position. That would be idle, and then this would be high speed. And so you can see my governor spring here attached to this arm, and this arm is controlled by this screw. Let's take a look at the procedure for the setting, and we'll take a closer look at the adjustment then. So again, we're going to locate specific information for our particular engine. We're going to gather a tack, and a flat blade screwdriver is my necessary tool for this task. We will go ahead and make sure the linkage is all still good and we've got a satisfactory static adjustment. Hook up the exhaust, we'll start and run the engine. We're going to go ahead and move the speed selector lever to the maximum engine speed position, and then we will make our adjustments. In this case, we'll be turning a screw. Other engines, you might have to bend an anchor tang or something else. Then we'll move it back down to the idle position, and we will set idle speed. Okay? And then we'll cycle it back and forth to make sure that we have good and stable operation. and then an instructor checkpoint. So let's take a closer look at the dynamic adjustment on this engine. So here's a close-up view of our speed selector lever and our governor spring lever over here, and the screw that manipulates the anchor point or tension on the governor spring. So right now we're in the off or stop position. I'll raise that up to idle and you'll see that it's not quite touching yet, and the throttle is moving freely, but I can manipulate it with my finger here. And then when I raise this to the full speed position, it stretches the spring and puts tension on it. And then if I take my screwdriver here, I can relieve the tension on it, and you can see the spring gets shorter and more relaxed. And then if I turn the screw in clockwise, how it stretches and adds tension to the spring. And so what we're doing when we set our top no load speed is dialing the tension on the governor spring till we achieve the RPMs that we're looking for. So in the high speed position here, my governor string has some tension on it. You can see that if I pull on it a little bit, it wants to pull back. So if I lower this in the idle position, there's a little bit of tension, but not as much. And you can see when I move this, that moves the governor arm, and it moves the throttle on the carburetor here. So this is idle. This is wide open throttle on the carburetor. And so right now you might be able to see that the end of the screw isn't touching this arm here, and this arm is allowed to be free at idle. So there's not really any tension on idle. But as I go up into high speed, this is no longer free, and now it has some spring tension on it, and the end of my screw is contacting the end of the lever on the opposite side of the pivot. So to adjust my speed, I would rotate this screw counterclockwise, and you will see that will lower the tension on this spring. And if I turn it clockwise, you can see that it will stretch or add tension to the governor spring. Okay, and so that's how we're going to make our adjustment, is by turning the screw clockwise for faster, counterclockwise for slower. And while we are making our adjustments, we need to monitor engine RPM, and we are going to do that with this particular device called a cerometer or vibration tachometer. And so how this particular tach works is you hold this firmly against the engine cover, and then you rotate this top dial until the end here is vibrating at its maximum width. And then once it's at its maximum width, because you'll have to cycle it up and down a little bit to find the point where it's vibrating the most and sweeping its largest. And once we find that point, we can look at our scale and the little pointer right here. See if we can get it to focus. Okay, so there we go, focusing. We would look at our pointer and take our reading to see what our RPM of the engine is. There's really two ways we can use this. We can find out what the current engine speed is by holding this on there and turning this until we've got our largest swept distance with the end of the tip, and then read the setting and make adjustments up or down accordingly. Or we can preset the dial to what we want. In our case, we're going to shoot for 3,400 for a maximum engine speed, which would be right about there. I can set it to 3,400, hold it on my engine, and then turn my screw up or down until I get the RPM that I've set the tach to. So let me go ahead and change your position so you can see things better. Restart the exhaust, and we'll go ahead and do the procedure. Okay, I got the exhaust on again. I've got the accelerometer or vibration tachometer preset to 3400 RPM, and I've set up a dark background so that you can see the tip a little bit easier on camera here. I've reset my speed selector lever to the idle position, so we'll go ahead and start the engine. We'll let it stabilize. We'll bring it up to top no load speed in the high speed position. We'll let it stabilize, and then I'll take my screwdriver and adjust it until we find 3400 RPM. Vibrating a whole lot because we're not at 3400. Let's go ahead and do an idle RPM check first. see if we can get this thing to focus. But yeah, there we go. We're just a hair above 3,400 RPM for our top no-load speed after rechecking it. And so that's how these vibration tachometers work, as well as how you dial in a top no-load speed on this engine for dynamic governor setting. So once you've got everything dialed in, this is where you'd want to get your instructor checkpoint and have your instructor verify that your idle speed and your top no-load speed are dialed in as desired and the governor is operating properly. A couple of friendly reminders or tips here is be careful of the hot exhaust and moving parts of an engine while attempting to make these adjustments. Each engine may be configured slightly differently, and so the mufflers and the moving portions of it may be in different areas, and you have to be very conscientious of where you are in relation to the hot or moving components of the engine or piece of equipment that you're working on. Another friendly tip here is, at least for the trainer here, make sure that you utilize the holes to hold your tools, as when the engine's running, this whole table's vibrating, and anything left loose on the table will vibrate and find its way to the edge. So go ahead and utilize the holes. That way your tools will be there when you reach for them, and you won't have to go chasing tools on the floor. So anyways, that's how we do the static and dynamic governor adjustments on this particular Tecumseh engine. Hopefully you learned something, and thanks for watching. We'll see you next time.